And then I realized that technology is far more interesting. My main transition point was that I wanted to run my own startup, but I was always afraid to. A startup has many parts, right? And the product is a small part. And the only way to really know how to run a startup is to be in one. I had the opportunity when I was a visiting scholar in MIT. During that time, there was a startup, an Uber for X startup. Uber for critical needs. It's called Uber for pinch moments, called pinch favor. We did that. 6 months later, the company was bankrupt, but at least we learned a lot. We lost 600,000 US dollars. After that, I founded a few companies. One of them is machine learning pipelines. That's Loretta.io. That's my own company. I also have a couple more. One of them that does petrochem solutions, and the other one is Estelle Tujo Singapore. That's actually a bad idea, but I'll talk about that later. Next slide. So today I'm going to talk to you about 3 things. I'm going to talk to you about it as quickly as I can. I'm going to talk very quickly about AI, and the most important thing about AI today is the part where it goes from, oh, I can recognize humans at a distance, to, oh, I can predict what the next thing that happens better than a human. So AI is the same as every other technology in the past. It is a core implement of an industrial revolution. And every industrial revolution is the way one type of technology, one type of work changes from human to machine. Steam engine, electricity, now it's AI. The interesting thing about AI is that when the steam engine came, it did things that were very, very hard, like hammering rock and turning it into a machine. When electricity came, we changed things from things like lighting the house and turn it into a machine-based thing. AI is about memory, okay? It's about memory. If your business is about remembering something and then repeating it, a system can do it much better than you do. Okay, that's AI. So we're going to talk about transfer learning, I'm going to talk about expert systems, and then I'm going to talk to you about that thing that has been recognizing people from the back just now. So if you were sitting down here, you saw that thing with person. I'm going to show you how to build the entire system in 20 minutes. Okay? After that, I'm going to talk to you about the 3 things that made doing this very difficult in the past, and then why all those things are gone. Okay, so let's go to the next slide. Let's talk about transfer learning. Transfer learning is the first step from specialized AI into general AI. What is the difference between specialized AI and general AI? Jennifer behind is specialized AI, and Jarvis Iron Man is general AI. Okay? If a system that can tell you one particular thing that is trained to teach you. If I train a system on 1 million images of people and it can recognize people, that is specific AI. If I train a system to play chess and it plays chess, is specific AI. If I train a system to play chess and then it plays checkers, that is a little bit more of a general AI. If I teach it to play checkers and then it learns how to play Dota 2, that is general AI. That's one step towards general AI. And the main thing is transfer learning. What is transfer learning? It is about taking knowledge from one problem and using it into a neighboring problem. Okay? Next slide, please. Transfer learning is told to be the next driver of ML success. Okay, machine learning success is about transfer learning. Okay, next slide. It is the main transition point between supervised learning, which is we train on 1 million pieces of data, we give it to you, then you learn how to interact with that data, to unsupervised learning. Unsupervised learning is I take that camera behind and I just play it all day, and at the end of it, it recognizes all of you as separate people. That's unsupervised learning. Transfer learning is the in-between point. Okay? Next slide. Expert systems is the implementation of transfer learning using certain pieces of knowledge in the middle. Okay? Let me illustrate it using one of the things that our company, Loretta IO, does. If you go to the next slide, you will see, if you go to the next slide, please, you will see a system, okay? Take a look at the system and tell me what it does. This is a system that is to be installed in 18 shopping malls, okay? And some of those shopping malls might be in Indonesia. I won't tell you which. But you look at each of those blank squares. The blank square is a data input. The 3 data inputs that are green represents how you feel when you enter the mall. The one in purple represents what we know of you because you connected to Facebook, or we recognize your image and we connected you to a name. The things in blue represents the thing that we know about our mall. At the end of it, what could happen is that 5 minutes into your trip, you get an SMS saying you went to the wrong floor. Perhaps you actually wanted to buy something downstairs, so I sent it to your house already. Would you like to confirm it, or do you want me to cancel the delivery? This is a system called transfer learning. Why? Because the interesting thing about a system like this is that half of the information, right, the middle section, your persona, your feeling, your intent, your environmental awareness, are transferable to every building that you enter. And we can train the system once and reuse it over and over again. This is transfer learning, okay? The interesting thing is that the things on the right, I can have a different person provide me the data every time. Because we're doing this in Singapore, we have a company who puts a webcam in front of you when you enter the shopping mall, and it tells you your emotion, how happy you are, how unhappy you are, or whatever. But in Indonesia, it is easier, because in Indonesia, before you enter a shopping mall, you have to pass through a guard. When the guard says hello, we can just log whether you said hello back, and then we decide how happy you are. Easy, right? From there, you have the attention model. The attention model is this thing called intent, I-N-T-E-N-T, intent. It is called desire. Everything you buy is fulfilled desire. Everything that you didn't buy but you wanted to buy is what I'm supposed to advertise to you lah. Right? That is called intent. The reason why companies like Tokopedia and Lazada are beating people like Sogo is because when you do window shopping, all the data goes to the mall. When you buy, your data goes to Sogo. The mall and Sogo does not share information. But if you were in a website, wherever you entered the website from, right, is provided to you by Google Analytics. It'll tell you, oh, I logged in from google.co.id. This person logged in from google.com.sg, probably from Singapore, right? Could be Indonesian, but now in Singapore, that's why .com.sg, right, location. Once he entered, he clicked into fashion for like 5 minutes, and then they bought something from the electronics store. Why? Because actually the person wanted to buy something in the fashion realm lah, but then the husband told her that she must buy something from the electronics store lah, right? So she bought from the electronics store, but am I going to market to her all the electronic products? No what? I market to her all the things that she clicked on but she didn't buy. That's the intent model, right? The intent model is something that is built from your window shopping data. It's something that you can easily build for an online store. Now you can build it for an offline store. This is where AI comes in, because we recognize your image. We recognize your voice. If you walk into Changi Airport in Singapore, if you say something that sounds like bomb, you will be tagged. You don't even need to do anything. You just need to accidentally say bomb. Go to Swenson's. How much is the earthquake? He want to make earthquake in Singapore. It's very easy. You don't ever need, they only just check for the keyword and they are recording volume. They are recording volume in 2 of the 4 terminals. Which 2 I'm not going to tell you, okay? But 2 of the terminals, they're recording everything that you say, right? So this is where the information comes in. Once you get it from different areas, that part you can build. It's easy to build. The center part is transferable across different areas. That is transfer learning. Go to the next slide, please. So the point of it is this, right? If you are a startup and you wanted to be in the AI space, you can do one of 2 things. You can either be a data input, of which there are many. You can do image recognition, like the camera that you will see later, and I'll show you how to build. You can do emotion recognition, free open source software. You just download, and then you just applicate. You just put a web front on it. You can sell it as a software. Warning: the amount of money to run that in real time is more expensive than Indonesian is willing to pay. We've already tried that. It takes $3,000 for the VPC, right? So very expensive. $3,000 US for the VPC. If you, however, want to grow big, if you want to be a $1 billion business, you build the Transfer Learning Center, right? One algorithm sell to every mall in the world. Choose whichever input. Yeah. So they are definitely going to take over because it's so lucrative to build that. The question is, which side are you on? Let's go to the next slide. I advocate that you're on the AI side. Anyone here think that AI taking over the world is a bad thing? Yes? Too bad. No choice. So I'm going to show you how to build an image recognition system. If you click through, click to the next slide. Can you click to the next slide, please? I'm purposely going to give you all the code from deeplearning.ai. Okay? The reason for that is because in 20 minutes, I can show you all the code, but if you want to understand it, there is 10 hours of lecture online that you can download, and it will teach you through the same code, right? So you can just go through it over and over again. Also, the solution, if I put it up, they will take it down, right? So I'm not allowed to show the solution online because some people copy, right? So what I'm going to show you is how to build an image recognition system, the whole image recognition system, okay? There are actually 2 parts. One is called object detection, and the second is image recognition. Okay? Object detection is the idea of taking a big image, something like this, and detecting that that particular square has something important in it. Then we will take that square and we will do image detection on it, and we will identify that in that square there is a person. Anything that has more than 1 square, you must have object detection. If your whole image is 1 person, right? The image is like this, then you don't need object detection, you just do image recognition. Oh, this is a person, right? It's probably Galvin. Okay? I will teach you, the way that it will run here is that it will include 3 important things: Keras, TensorFlow, and NumPy. It's all designed in Python. Why is it designed in Python? Because Python has the least lines of code to make something fairly straightforward. Because you are using TensorFlow and Keras, it will then when you build it, it will build down to C, so it will be fast. Okay? So don't code in C, because we don't have enough time in our lives to build AI in C. However, the one that was running from behind you, that was coded in C, that is why it's very fast. But again, try not to, it's probably very difficult to do it on your own. What you will see here allows you to do 3 things. Keras means that you will share in the high-level systems, which means that you won't have to build very, very complicated hand-coded things. They are pre-built inside. Keras is from UC Berkeley. TensorFlow is from Google. So you have the best academia and you have the best company AI providing all of the systems for you. In the next slide, you will see why that is very, very special. And NumPy means that you will be, by default, able to run your code on GPUs. That means you can run 1 core and you can run at a certain speed. You can buy $200, one GTX 1070, and you run 1,240 cores simultaneously, it will actually run 1,240 times faster. Okay? All of that hardware is pre-coded in, right? So you don't have to worry about that. If you go to the next slide, the first and most important difference between image recognition systems, which is in a class called convolutional neural networks, and normal neural networks, is this thing called feature extraction. Feature extraction used to be the most complicated field in AI in 1995. Okay? And it was so complicated that when they started going into this part of the field, AI stopped developing. That is why in 1995 to 2000, there was nearly no AI progress. From 2000 to 2010, AI was progressing, but it was always worse than hand-coded statistics. Okay? 2012, AI became better than most statistical algorithms like SVM, support vector machines. The reason for that is only half because of the fact that you have GPUs and it's very fast. The other half is because of things like Keras and TensorFlow. You'll see in the next slide why. But what does a model abstraction do? What it does is that it takes your image. How AI reads the camera is that it will take the number of pixels, maybe 64 by 48 pixels, and it will split it into RGB. So it will then create one column of numbers, 64 times 48 times 3 numbers long, one column, and it will train on thousands of columns at one go. So that's a square matrix. And then that matrix will be pushed through a system to capture things that are similar across, okay, the numbers. That's all. That is deep learning. Okay, that is all there is to it. In convolutional neural networks, they don't pass the numbers across. They will pass the numbers through a system that finds special things. Find all vertical lines. Find all horizontal lines. Find all dots. Find all dots that are 2 pixels wide. So you have to build hundreds of these models. It used to be really, really hard. Can you click to the next slide? You will then take these things and you'll push it through the neural network, and then you'll get a number at the end. Can you click to the next slide again? Can you click on the next slide? Okay. It's a bit blur on the screen, but I want to show you how to build 32 features in Keras. There is one line there. Okay, the line says convolve. So take your number and turn it into 32 features. The code is features equals 32. That's all. Okay? It's one number. You can't really see it. It says convolve 2D bracket 32, comma 2, comma 2. What that says is that it will then take whatever you have, it will turn it into 32 different varieties of features, all pre-coded for you. Okay? And you just need to say that each feature is 2 by 2 pixels in size. That 2 lines is all, those 2 numbers is all of the hand coding in the past combined into a single package of 3 different parameters. In the system that you have in the back, it actually says this. It says convolve 32, 2,2, convolve 64, 4,4, convolve 256, 4,4, convolve 512, 4,4, convolve 1024, 4,4, and convolve 3 more times, and then suddenly you can recognize everything in real time. Okay? It has no hand coding at all. The entire configuration is in a single text file that is only about 100 lines long. Okay? That is the level of abstraction available to AI today. That means that the really, really complicated image recognition systems, the Google image recognition, all of them uses only up to this level, and it's sufficient. Okay, it's sufficient. Okay, can you click please? Okay, this whole part, this whole section, I won't go into because it's significantly more complicated, but what you have up to that point will then take an image of anything that you have, right? It could be your face, You can take 50 images of your own face, then go to your friend, take 50 images of your friend's face. And you just put it into a column, and next to your face you put 1, next to your friend's face you put 0. And that is your data set, it's ready for you to run already. Okay, that is enough to build a system that you cannot sell because the only thing it does is recognize you from your friend. Okay? We click through the next few slides because we are just going to skip this slide. Click through again. Next, next. Okay, stop. So the reason why I put those slides there is because even though I knew that we would never go through them, because the slides are available online, that means that if you really want to create a system, all of the code is available. All of the code is available. You can copy and paste all of those into a Python notebook, run, Control Enter, Control Enter, Control Enter, Control Enter, it will run. Okay, it will run. So, but now you are on the AI side. Okay, now you're all on the AI side. You now have the ability to build your own image recognition system. You just need whatever data and you're able to build it, right? But there was a problem. The problem is that until a few years ago, you needed to be Google to have the amount of data required to train these systems. If on average the ImageNet system, ImageNet data set, which is a data set that you need to be able to compete against if you wanted to be like a data science champion on Kaggle.com, has 1.2 million images. Each image is about 320 by 240, so it's about 60,000 pixels. 60,000 pixels, 1.2 million images, 3 channels, RGB, you have a lot of pixels. You have a lot of numbers, you have to process all of that. If you process them one by one, it'll take a couple of lifetimes. Okay? But today I'm going to show you why this is not the case anymore in the future. So let me just go to the next slide. There are 3 things that have limited us as small-time developers from being able to do AI. The 3 things is complexity, because a lot of the high-quality AI solutions have always required a lot of hand coding. Hand coding means that there will be a PhD who will come and say, but if you remove this icon and you add 1 number to here, it becomes 5% more accurate. Okay, there's a lot of that in the past. Okay, the second thing is the amount of data. The amount of data that a person like us will have, it's not a lot, right? Amount of data that Google will have is that they are actually taking data from all of your systems, right? You're taking, Facebook has all the images that have ever been on Facebook. Google has all images that have ever appeared on Google search. It has a cache of it. Okay? The third thing is processing power. And processing power is a big deal because the laptop that you have, that you saw above, is a laptop that I have to bring separately because it's the only one that has a GPU on it. Right? Processing power is quite a problem in the past because it used to be that it takes a lot of effort, right, to be able to train the system. On average, if you want to train a system, you will take the data and you will test it maybe 10,000 times. Usually 10,000 times, if you're very accurate, you get to 90% accuracy on the training data, which means that on the real data, you get maybe 60%, only half right. Then you train another 20,000 times, usually you get to 70 or 80% if your system is designed properly. Still, maybe it will take 3 days, right? 3 days means that if you put one error in your code, 3 days later, oh, it's wrong. I guess I have to run it again. That's another 3 days. Okay? Today, all these things are gone. So let me tell you about this thing very quickly. So we go to the next slide. What you see is a web service that will appear on your laptop if you use TensorFlow. If you use TensorFlow, it will allow you to see every single element of your code, all the way down to this detail, immediately out of the box. That means that all of the complexity, all of the hidden features, all the things that you wondered why this part failed, maybe is it level 2 that failed, level 3 that failed, all of it is automatically available to you. If you were coding a web service, even if you're coding a web service, you have to code a second service to monitor your web service. right? And then you have to code another one to get the data for your monitoring service. And then you have to get another one to debug the code that comes to your monitoring service. Then your web service is like that, and then your debug is like this. Today, your TensorFlow is like this, and then the debug comes out of the box, so it's free. Okay? This is exactly the same system used by Google, even today. Although they have moved on to more complicated versions of TensorFlow, which are fairly different, but actually the board, the debugging is the same. Next slide. Okay, in the bottom right corner is an image that comes from a famous paper. Does anyone know what that paper is? One of the words on the paper is capsule. Does anyone know where it comes from? So the person who invented AlexNet, the person who invented the first truly successful deep learning system, convolutional or image recognition system, is a professor called Geoffrey Hinton. Okay? In 2012, he created a system that was 5% better than the competitor. Now, the difference between the bottom, the last place image recognition system and the top place image recognition system was 15%. So the worst one captured 85% accuracy, and the top one was, the worst one was like 50% accuracy, the top was 85% accuracy, which is 15% away from perfect, right? His was 10% accuracy, 10%, which means that only 10% wrong. Humans were 8% wrong. His system was almost as good as a human. That was the first convolutional neural network. That was in 2012. In 2017, he said that he has found a way to make convolutional neural networks obsolete. And he published his paper on the 2nd of November, 18 days ago, okay? 19 days ago. Okay, the paper is called Capsule Network, and the most important thing you need to know is that because of the way it's designed, it captures the same level of accuracy as your previous systems that needed about 100,000 data points with 6,000 images. If you have a camera running at 24 frames per second, how long does it take for you to get 6,000 images? Sorry, 4 minutes. So it's 4 minutes, right? So it'll take you 4 minutes to get enough data to run an image recognition system. 4 minutes, with one camera. With 4 cameras, it's 1 minute. Okay? Because of that, that means that you no longer need a lot of data. Next slide. The last thing is, of course, something that in the startup world we should all be fairly familiar with, which is serverless architectures. Today, once you have all this information, you can pump it into Google's ML or Google Brain, and it will cost you as many seconds as your data takes to process. On average, that costs you about $2 to train your system. Okay, it will cost you $2. If, however, all of you together decide that you want to build your own AI system, you each put $1 Singapore or 10,000 upfront. You buy a GTX 1070, and GTX 1070 is about the same speed as IBM Watson when it came out. Okay, IBM Watson, the one that beat Jeopardy, is about the same speed as today your computer game GPU. Okay, it's about the same speed, same number of processors, more cores. You get more cores than IBM Watson. Okay, and the funny thing is that the way that NVIDIA has pushed itself, the gaming laptop GPU is the most cost-effective GPU in the whole world today to buy. Okay, it is 8 times cheaper and only half as slow as the server-based GPU. That means if you buy 2, you are 4 times cheaper than the one in the industrial system, and same speed. Okay, it also comes with SLI. It means that when you're not coding, you can play Call of Duty in the highest frame rate, and then you can go back to your AI. You just can't do both at the same time. Okay? Next slide. So that's my conclusion. My last conclusion is this. So with all of these things, right, that means my conclusion is very straightforward. The AI is coming. The robots will definitely take over. If you are an entry-level manager, companies like myself and expert systems around the world are going for your level of jobs. It's no longer the entry-level jobs. Okay? Line managers, which were always an inefficiency, are going to go the way of the dinosaurs, and we're very sure that that is something that people want to do. So what you need is that if they are taking over, the only way to survive is to be one of their technicians. Right? Have you ever watched any movies where there are large evil empires? They are not always good guys. The good guys don't not always have Deus Ex Machina on their side. They don't always suddenly win, right? And so, so get on the bandwagon. Then get on the bandwagon. Learn these things, and it's definitely something that even as an individual are available to you. Okay, that's all. Thank you.